So in this next question, we've been told the probability that a coffee vending machine will spill a drink is 25%. The machine is now serviced, and after the service, the next 20 dispensers of drinks are recorded. It's found that only one drink is now spilt. Test at the 1% level of significance whether the proportion of spilled drinks has reduced. So this is a hypothesis test question, and I hope that you can recognize that. We're going to pull out all of the important information and use that to state the null and the alternate hypothesis. So firstly, we were given a proportion of spilt drinks, and that was 25%. So 25% of drinks are going to spill. Basically, the machine is putting too much liquid into the cup and it's overflowing. The machine is now serviced, so they've tried to fix the machine. They want to fix that problem. And after the service, the next 20 dispensers of drink are now recorded. Well, this is our sample. We're sampling the next 20 drinks and we want to see what happens. So the next 20 drinks, that's our fixed number of trials, are our sample. In that sample, we only saw one drink spill. So our observed value is 1. Only one of these drinks is going to end up spilling. We're going to use that as our test statistic. We're going to use that to calculate our p-value. We're asked to test at the 1% level of significance whether the proportion of spilled drinks has reduced. So here we both have the significance level, and we've been given a clue that we're testing in the direction of reduced value for p. It's a one-tailed test. The context of the question should have given us that. We know that there should be fewer drinks spilt if we've just gone and fixed our machine. But here the question has also told you we're going in that negative direction. Okay, so let's turn this into our hypotheses. The parameter is always p, so we have p equals 0.25, and for the alternate hypothesis, p is less than 0.25. We have enough information to state the distribution. So we have a binomial distribution where x follows a binomial, n is 20, p is 0.25. Now the expectation from that is n multiplied by p, and that gives us 5. So we would expect 5 drinks to spill in a normal situation with this machine. So that's before it was fixed, we were expecting 5 of the drinks to spill. We only saw 1 drink spill. Yes, it's lower than 5, but is it a significant result? I'm going to put that all on a diagram. So 5 is the expected, 0 is the minimum, and 20 is the maximum. Just a reminder, we have a significance level set at 1%. I always want to make sure you write down alpha. So 1%. And we're going to place 1 on this diagram. This shaded region represents a probability. The probability of less than or equal to 1. And we're going to calculate that and compare it to our significance level to draw a conclusion. So let's go ahead and do that. The probability that x is less than or equal to 1, on your calculators it's BCD 0, 1, 20, 0.25. That equals 0.0243. Now let's compare that to our significance level. I already know it's 2.4% and the significance level was 1%. So it's above our significance level. We do not have a significant result. But formally, we just want to write this comparison. So 0.243 is greater than 0.01. This is not significant. From here, we can make our 2 conclusions. One of them is mathematical and the other's in context. The mathematical conclusion is that there is not enough evidence to reject H0. We just don't have enough. This was bigger than the significance level. Our contextual conclusion, we need to talk about this vending machine and the way that it spills drinks. So, from our sample, we do not have enough evidence to believe that the proportion of spilt drinks has reduced. Our sample doesn't give evidence to show that. So a standard hypothesis test question, make sure you're getting all of these points in to maximize the marks you get in an assessment.